How are you doing? Bismillah ar-Rahman ar-Rahim al-Hayy. How are you doing, ladies and gentlemen? Once again, we are again in further topics and also a complementary lecture here to disambiguate and to clarify more associated and more correlated, if I will be more specific in statistical term or in statistical terminology, more correlated topics here associated to the science of materials and material engineering and variety of fields. Today we're just going to have to disambiguate or even clarify and explain the crystalline and vector and plans. Crystalline vectors and plans. Crystalline or crystalline vector and planary. The crystalline vector and planary, most of the times, as you can see right here, here as you can see, the crystal vectors and planaries. Today a very comprehensive lecture here for the lecture that actually already been through. Actually, all of us already been through, and all of us discussed already by us, or even we already discussed that the lecture already discussed is actually pretty much correlated or even associated to the atomic packing factor, with a very important or very essential topic to be discussed, and a very essential topic to be interpreted to the first stager students or first stagers that actually consist of a very important points or very important notations that actually can disambiguate or even clarify the atomic physics methodology that most of our students actually go with in material science. Most of our students are actually attached to or have to comprehend in the material science, or most of our students have to comprehend in material sciences and material engineering at the same level or in the same time. The crystalline vectors and plans. For most times, the crystalline materials features is actually associated to the atomic density, whether the linear atomic density for the unit lengths or the planar unit atomic density for the unit areas. Accordingly, when to deal with the materials is very advantageous to determine vectors and special particular crystalline levels or even particular crystalline plans. Most effective and the easiest method to do so is to study the vectors and the plans crystallinely by the unit cell. And we will clarify this and we will disambiguate so by studying the vectors and crystalline plans in the cubic crystal lattice structure system, as you can see right here in front of you. Article 151. The crystalline vectors in the cubic crystal lattice structure system. The vector in the cubic crystal lattice structure system is actually expressed or even denoted by three bounded square brackets integer digits, and the negative integer digits are expressed in the digit upward line, or the line in the digital upward for size the vector 1 to 1. The upper digital and the line are the top of the digit, or the integer negative digits. The integer negative digits is expressed by a line at the top of the digit. For size, the vector 1 to 1 and the vector I-10, as you can see right here for you. And the length vector I-10, I- means or I- indicates. يعني معناه I- هنا الفكتور يمثل بثلاث محاور، المحور X والمحور Y والمحور Z. The vector can be expressed or even denoted by three axial digits or three axial digitally figures to be expressed in the three-dimensional metric or in the three-dimensional spatial metric. يعني ممثلة في الفضاء المتري ثلاثي الأبعاد على شكل مكعب in the form of a cube. 1 to 1 and the vector I-10, and the light vector I- indicate I-10, and the light vector I- indicates. 1. In order to read or to graph the vector, point of origination or a point of origin has to be assigned with 3 axes coming out of, and to drawn right from in the directions of x, y, and z, as illustrated in figure 111. The positive directions of the axes are always as illustrated in the figure, whereas the point of originations is selective out of the 8 corners in the cubic crystal lattice structure system, as you can see right here in front of you. يعني تستطيع أن ترسم نقطة الأصل في أي مكان في الفضاء المتري ثلاثي الأبعاد in the spatial 3-dimensional metric. Here, the point of origination with the axis or the perpendicular 3 or orthogonal 3 axes drawn right from, or graphed right from, sketched right from، يعني مرسومة منها. drawn وsketched وgraphed هن ثلاث مصطلحات تشير إلى رسم المحاور من نقطة الأصل، من نقطة تنطلق منها المحاور المتعامدة. From a point at which the 3 perpendicular or even 3 orthoperimetric or even 3 orthoperimetric axes are launching from. يعني orthoperimetric يعني المحاور المتساوية القياس، المحاور المتعامدة متساوية القياس. The three orthoperimetric axes. The 3 orthoperimetric axes are the x and y z launching from the same origination point drawn at any spot in the 3-dimensional spatial metric. يعني في خلال نقطة الأصل أو من خلال نقطة الأصل تنبثق المحاور الثلاثة، ونقطة الأصل مرسومة في أي بقعة بالفضاء ثلاثي الأبعاد، الفضاء المتري ثلاثي الأبعاد. Here the figure 111 we already talked about and we already indicate too the origination point and the axis of the cubic crystal lattice structure systems. Good. Article 1511. In order to read any vectors from any cell, we can only conduct the following steps here to read any vector from any cell. Point of originations is selected from the entire cubic corners where the vectors is passing through. Maintaining or via maintaining the axial directions as illustrated in figure 111. يعني يتم اختيار نقطة الأصل من أركان المكعب بحيث يمر بها المتجه مع الاحتفاظ باتجاهات المحاور كما في شكل 11. B. State or find the vectoral projections mapped to the 3 axes in terms of the cellular lateral lengths. A. يعني نوجد إسقاط المتجه على 3 محاور. إسقاط المتجه هنا vector projection على 3 محاور mapped to the 3 axes، يعني على 3 محاور. In terms of بدلالة طول ضلع الخلية. The cellular lateral length A constant. A is a constant. Constants in all 3 dimensions in the quadrant at which the cubic crystal lattice structure system or the cubic review coexist right at. يعني في الفضاء المتري ثلاثي الأبعاد in 3-dimensional spatial metric lattice system at which the cubic is coexist at، يعني الذي يتواجد فيه المكعب. G 3 or the third point. The digits are multiplied. The 3 projections are multiplied or even divided with a common factor to be reduced to smaller. D. The integer digits are placed in the square brackets or are bounded in square brackets, capital Y, capital U, capital V, capital W, where U is the integer digits of the projection mapped to the x-axis. V capital is the integer digit for the projection mapped to the y-axis. W is the integer digit for the projection mapped to the z-axis. Figure 112 illustrates the examples. يعني توضع الأرقام الصحيحة كما قلنا بين أقواس مربعة مثل معاملات ميلر التي سنأتي على ذكرها لاحقا، such as Miller indices which we're about to mention subsequently، التي سنأتي على ذكرها لاحقا. توضع الأرقام الصحيحة كما قلنا بين أقواس مربعة U V W، حيث U هو العدد الصحيح للإسقاط على محور X أو الإسقاط في محور X is the integer digit for the projection mapped to x-axis. mapped يعني للإسقاط المسقط أو للإسقاط إلى محور X. V هو العدد الصحيح للإسقاط على محور Y. V is the integer digit for the projections mapped to Y-axis. And W capital is the integer digit for projections at the D or at the Z-axis. And the figure 112 subsequently will illustrate the examples, as you can see right here in front of you. هنا الشكل 112 للإسقاطات. Here figure 112 vectoral examples يعني أمثلة المتجهات. هنا نقطة الأصل والإسقاطات ممثلة باللون الأحمر. Here the point of origination or the origin points at which the three orthoperimetric perpendicular axes are launching from, and the projection mapped over particular plans or projection mapped to particular plans. يعني الإسقاطات الموجهة channeled projections or the projection channeled to particular plans إلى مستويات معينة. جلقة graph a vector رسم متجه. Usually following the subsequent steps here to graph the vector في رسم المتجه. A. Draw the cell and the point of originations and the entire axis, an entire orthoperimetric axis as illustrated in figure 111, taking in consideration that the positive directions of the axis are the arrow directions stabilizing point of origin with making sure that the point of origin is stabilized مع تثبيت نقطة الأصل. B. If the vector is capital U, capital V, capital W, commence the course or commence the track from the point of originations mapped to x-axis with a distance of amount U, with a distance or distance estimated as U from the unit, from any unit. The unit is A, the constants, in the directions of the x-axis. And if the U is positive, or the capital U is positive, encounter x-axis wise, and if U is negative, from the new point we commence motion distance V. We commence to move in a distance V parallel to y-axis, and if V is positive and counter y-axis wise. And if V is negative, from a later point, we just gonna have to commence moving parallelly to the z-axis with a distance estimated as W capital in the direction of z-axis. And if W is positive, counter z-axis wise if the W is negative, as you can see right here in front of you. يعني إذا كان المتجه هو U V W، نبدأ المسار من نقطة الأصل على محور X، مسافة قدرها U من الوحدات. وحدة هي A. Distance U of units. The unit is A. As you can see right here. The unit is A in the direction of x-axis. If U is positive in the counter x-axis y. If the U is positive and in the counter x-axis y, if U is negative. يعني في عكس اتجاه محور X إذا كانت سالبة. U. من النقطة الجديدة نبدأ التحرك مسافة V موازية لمحور Y. يعني من النقطة الجديدة التي اتجه إليها المتجه U. From the new point at which the vector U is heading to. We commence drawing vector V parallelly to y-axis. يعني نبدأ برسم المتجه V موازيا لمحور Y. If V is positive and counter y-axis or in the inverse y-axis if V, in case of V is negative. من آخر نقطة, from the latest point, we begin moving parallelly to z-axis, perpendicularly or longitudinally. يعني من آخر نقطة نبدأ التحرك موازيا وطوليا لمحور axis. أكيد سيكون المحور طولي. From the latest point, we begin or even we commence motion parallelly to z-axis with a distance of W in the direction or in the direction of Z-axis. If W is positive and in the direction of inverse Z-axis in case of W is negative. G. We reach the origin point with the latest point. We attach the origin point with the last point we ever come up with, and the vector is U capital V capital W capital. D. This vector may out of the cell or even the adjacent cell and give the same meaning because all the cells are identical. H. An example for that illustrated in figure 113. يعني مثال للكلام ممثل في الشكل 1.13. Figure 113 is an example of vector graph. يعني شكل 1.13 مثال لرسم متجه. This is the vector as illustrated in figure 113, right here for you, the vector indicated, or the vector denoted as 0 I-1, 1 I-0. The crystal plans in the cubic crystal structure lattice system. The plan is actually represented, or even the plan is actually denoted in the cubic crystal lattice structure system with three circular, or better said, three circular brackets bounded integer numbers or integer digits, and the negative integers are expressed by a line to the top of the digits as a result of this, or for size, or as example for 1 1 1, the vector is 1 1 1, I-01, I-01. In the plans, the integer digits are so called, or even the integer digits are called, the integer great digits are called as Miller indices or Miller coordinates. In order to regard or even to draw any plan, a point of origin has to be assigned, and all three axes as the same as the drawn or graph or drawn or graphing vector, just like we already stipulate, or even just like we already said before. And three axes has to be drawn in the direction of Z, Y, X, as illustrated in figure 111, and the entire positive directions should be all, or the axes, or the entire axial positive direction should be always as illustrated in the same figure 111. Where the point of origination will be selective out of 8 corners of the cubic fabric. Reading Article 1521. Reading plans to any cell. يعني قراءة المستويات لأي خلية. We can only conduct the following steps here to read any plan to any cell. If the plan is actually passing through the origin, we select another point of origins maintaining the axial directions. يعني إذا كان مستوى يمر بنقطة الأصل نختار نقطة أصل أخرى ونقطة أصل ثانية مع الاحتفاظ باتجاه المحاور المبينة. B. We're just going to have to find the intersection points with the axis, taking in consideration يعني نوجد نقاط التقاطع مع المحاور مع الأخذ في نظر الاعتبار الاتجاهات السالبة والموجبة positive and negative orientations. B. Parallelism التوازي. E.g. بمعنى إنه إذا كان المحور موازيا, and if the axis is actually parallel to the plan موازي للمستوى, the point of intersection نقطة التقاطع تكون في ما لا نهاية, will be to the infinity, will be in the infinity. G. نوجد مقلوب نقاط التقاطع. We find the intersection points reciprocal مع معرفة أن مقلوب ما لا نهاية هو صفر, knowing that the infinity reciprocal is 0. D. If it's necessary, we multiply the reciprocals in any common factor to get H. We place the integer digits in two circular place the integer digits bounded between two circular brackets HKL, where H is the opposite digit to the x-axis, and K is the opposite digit for the y-axis, and I is the opposite digit for the z-axis. Example for these, or example for the axis, as you can see right here in front of you, illustrated in figure 114. معاملات ميلر، رسم مستوي في الفضاء ثلاثي الأبعاد. Drawing a vector or an example for a planar motion or planar graphs in the three-dimensional spatial metric. Three-dimensional spatial metric يعني في الفضاء ثلاثي الأبعاد أو الفضاء العيني ثلاثي الأبعاد، المادي، العيني المادي يعني الفضاء المرئي. spatial يعني المادي أي المرئي. visible the sighted media, the sighted metric. metric هنا الفضاء المتري، الفضاء الإقليدي. رسم مستوي. هنا المستوي 1 1 0 مرسوم خارج المكعب. Here the plan 110 as illustrated or as indicated in figure 115 is actually very example to draw a plan. Is actually drawn out of the cubic or out of the cubic solids and the second quadrant في الثمن الثاني octadrant, the octadrant, in the second octadrant يعني في الثمن الثاني، لأن هناك في الفضاء ثلاثي الأبعاد سوف نتعامل مع الفضاء ثلاثي الأبعاد سوف نتعامل مع 8 أرباع. We're just going to have to deal with 8 octa quadrants. We're just going to have to call it 8 quadrants or octa quadrants. octa quadrants يعني الأرباع الثمانية or hexa quadrants أو الأرباع الستة. سنتعامل مع 6 أرباع. Figure 115 as you can see here usually following the given steps here in any planar graph في رسم أي مستوي. عادة نتبع الخطوات التالية في رسم أي مستوي. We draw the sails and the origination point and the axis illustrated in figure 111, taking in consideration that the positive orientation of the axis are the orientations stabilizing or taken in consideration stabilize the points of originations. B. If the plan HKLs, if there is actually a plan HKLs, we find or reciprocalize the digits and determine the points for the axis. The point and the z-axis distanted from the origin point by 1 over h of units A, B in the directions of x-axis if the value is positive, and counter the value in case of the value is positive will be in the direction of x-axis, and counter x-axis or in the inverse x-axis if the value is actually negative. In the same way, determine the points to the y-axis that actually distanted 1 to k of units A of the origin points, and in the z-axis which distanted 1 to I, and also the z-axis of units A of the origination points. We attach all 3 points to get the plan HKL. G. إذا كانت إحداثيات ميلر يساوي 0. إذا كانت إحداثيات ميلر كلها حشا والله. If the Miller indices are 0, we just can determine the all other points and attach them and draw between them and draw parallels or even parallels for the opposite zero axis. يعني نصل بينهما ونرسم منهما موازيات parallels للمحور المقابل للصفر. D. If there is actually 2 other coordinates, each of them are 0, we determine the point and we draw 2 parallel lines for the opposite zero axis as illustrated in figure 115 plan graph example. As illustrated in figure 115 plan graph example, as you can see right here from you. Well, a new article with a new very important, very essential topics that are actually mostly correlated or even mostly attached to the material science and the crystallography or the crystallology that we're actually discussing right now or even reviewing, as you can see right here in front of you. يعني مقالة أخرى أو موضوع مهم آخر مهم، موضوع مهم عن المتجهات والمستويات البلورية، متعلق أو مرتبط بالفيزياء الذرية التي نتحدث عنها الآن الخاصة بالمواد البلورية. Pretty much associated to the crystal physics or even to the atomic physics, pretty much associated or even specialized by the crystalline materials. The atomic density for vectors and plans. الكثافة الذرية للمنتجات والمتجاوزات. الكثافة الذرية للمنتجات, the atomic density of the vectors, is simply the amount of atoms at unit length of the vector. It can be defined as follows. The vector density, amount of the atomic radius or even amount of the diameter that intersects with a chosen length of the vector. That intersects with a selected length of the vector to the selected length of the vector. As example, calculate the vector density 011 or 110 of AU if you knew that the lattice constant is 0.08 nanometer. The lattice constant A here is the lateral length of the cell. Lateral length of the cell يعني طول الضلع الخلية هو ثابت الشبيكة. Nanometer, nm is the nanometer. Know that the AU cell is FCC. The AU cell, AU يعني الذهب gold, AU cell is FCC. يعني من نوع FCC, face center to cubic crystal lattice system structure. The solution. Figure 116 disambiguate the vector 011. 0110. The 0 here is the z-axis. So the z-axis will contain no, as you can see right. 1 only the x and y axes are variable. Only the x and y axes are variable. So the entire circular figures or the crystalline graphs will be drawn right entirely at the quadrant of the xy plane. يعني هنا من المتجه الزد اكسس صفر والاكس محور الزد هنا المحور لا مو محور الزد صفر كذا كلها هنا الاكس واحد والواي واحد لذا سيكون رسم مو محور الزد يعني ليس محور الزد محور الزد عظيم محور الزد هنا محور عظيم يعني ممتد من النقطة الأصلية إلى أعلى في الاف سي سي هنا في الاف سي سي الخلية الاف سي سي هنا كما ترون الرسم في الاكس والواي في مستوي الاكس والواي in the plane x y here and z is 1 and x is z is 1 and x is 1 and y is 1 so the graph will be done in the 3-dimension spatial metric لذا الرسم سيكون في الإحداثي ثلاثي الأبعاد سيكون في الإحداثي ثلاثي الأبعاد إحداثي مينر 1 1 1 هنا الواحد 1 1 هو للزد وللإكس للزد وللإكس وكذلك للواي. Figure 116 the vector 111 in the FCC. هنا مو 0 هنا ليست الزد صفر هنا الزد 1 فقط هنا الزد هو 1 تصحيح للمعلومة هنا الزد هو 1 له قيمة z is valuable. The selected length of the vector is the face or even the frontal hypotenuse. الطول المختار للمتجه هو وتر الوجه hypotenuse هو الوتر equals to square root of 2 by a يعني جذر تربيع الاثنين في a في ثابت الشبيكة. Atomic amount or atomic amounts of diameters or the atomic diameters that intersect with the length given يعني عدد أقطار الذرات التي تتقاطع مع الطول المعطى هي 1 إلى 2 زائد 1 زائد 1 إلى 2 1 to 2 plus 1 plus 1 to 2 equal to 2. Density of the vector equal to 2 to square root of 2a يعني 2 إلى 2 جذر 2 في 2 الجذر التربيعي 2 في lattice constant في ثابت الشبيكة. Here 2 by square root of 2 by 0.08 atom. Here 2 by square root of 2 by 0.08 by 10 to the power 6 millimeter to atom. So we're just going to convert the nanometer to a millimeter by multiplying the nanometer value by 10 to the power 6. يعني هنا يجب علينا تحويل وحدة النانومتر إلى مليمتر بضرب الوحدة النانوية بالقيمة 10 إلى القوة 6 by multiplying the value of nanometer by the value of 10 to the power 6. 10 to the power 6 by 3.466 atoms for each millimeter. This is the vector density. يعني هذا هو كثافة المتجه. Good. Now article 162. The atomic density of plans, or the planar atomic density. الكثافة الذرية للمستويات. Simply the amount of atoms in the unit areas of the plan and can be defined as follows. The amount of atoms at which their origins are at a selected area of the plan. The amount of the atoms at which their origins at a selected area of the plan. يعني عدد الذرات التي تتواجد مراكزها على مساحة مختارة من المستوى. To the selected areas of the plan. Good. Well, an example. Calculate the atomic density of the plan 1.111. Also here, the 0 is going to be 1. Also, just like the previous example, just like the formal example we already discussed. Here, for the tungsten, if you know that the light constant A is 0.30 nanometer. So the nanometer, as well as here again, used to be or required to be converted to the millimeter by multiplying the nanometer value by 10 to the power 6. That the tungsten, if you knew that the tungsten cell is a BCC center cubic or body centered cubic crystal lattice structure system cell. يعني خلية شكل مكعبي من نوع BCC أو خلية متمركزة الجسم. The solution. Figure 117 is ambiguate the 111 level or the 111 plan and the BCC cell, as you can see right here for you. Their section is actually the intersection or the plan is drawn diagonally within the cubic fabric in the three-dimensional spatial metric. يعني المستوي مرسوم قطريا في الخلية المكعبة المرسومة في الفضاء ثلاثية الأبعاد. شكل 1.17 figure 117 is the plan 111 and the PCC. The selected area of the plan is a rectangle with a length of the square root of 2 by particularly multiplied by A and the width of A as illustrated in the figure. يعني المساحة المختارة للمستوي هي مستطيل طوله جذر 2 في ثابت الشبيكة the square root of 2 by lattice constants and the width A وعرضه A كما هو موضح بالشكل 1.17. The selected area المساحة المختارة هي square root of 2 by A times A يعني جذر 2 في A في A. عدد الذرات في هذه المساحة atoms in the area 1 plus 1 times 4 1 plus 4 times 4 يعني كثافة المستوي density of the plan is 2 by square root of 2 by A squared 2 by square root of 2 by A squared. So 2 square root of 2 by 0.30 squared nanometer squared per atom. Nanometer squared per atom. يعني 2 انكذب التربيع ل2 في 0.30 نانومتر تربيع القيمة تساوي قيمة معينة نانومتر تربيع للذرة. لذا سنحول النانومتر تربيع إلى مليمتر تربيع بضربه في 10 أس 12. لأن إذا حولنا النانومتر إلى مليمتر نضربه في 10 أس 12. So here we have the 2 by square root of 2 by 0.30 squared by 10 to the power 12 millimeter squared per atom. So the planar density is 1.53 by 10 to the power 13 atom for each squared millimeter. Or millimeter squared millimeter for each atom. Squared millimeter per atom. The family or even the collection of vectors and plans in the cubic crystal structure system. the collection of vectors. The collection of vectors typically are the equal vectors that are equi-atomic density vectors. Equi-atomic density vectors. And the cubic crystal structure system are the vectors has the same coordinates regarding the arrangement or the assortments, such as the vectors 001 or 00I dash or 010, or 0I dash 0, 100 or I dash 00, has the same atomic density consequently as of the same group. The group is denoted by add angular squares or in angular brackets, which means that all vectors or the formal vectors of the group are 001. Planar family or planar groups. planar group. Planar group typically are the atomic density plans, and in the cubic crystal structure systems are the plans have the same coordinates regarding the assortments, such for size the plans of 0, 1, 2, 20I and I dash 20 have the same atomic density consequently as the same group, and the group can be denoted here as the square brackets or the brackets, or be like the vectoral expression, the vector arc-bounded expression. Yeah, the arc-bounded denotation, the vectoral arc-bounded denotation. How do you feel it? How do you feel expression? والله. 0 to 1. Yeah. Summary of chapter 1. We already discussed in the chapter the fundamentals of atoms, of electrons, protons, and neutrons, and atomic weight and atomic number, and very orbits. Then we concentrate on the electronic distributions, on the atomic orbits, and the importance of the essentiality of the electrons in the later orbits, the equivalent electrons. There we discussed the relevance between the bonds, or inter-atomic bonding relevance, and the electronic distribution. Then we talked about, or we discussed already, the fundamental bonds, inter-atomic fundamental bonds of ionic bonds and covalent bonds and metallic bonds, as well as we study the summarizedly their bonds or the secondary bonds. They were just a very essential introductions to identify the engineering materials and divide them into potteries and polymeric materials and metallic materials. Then we discussed that the very top characteristics or the peak characteristics for each. And then we study the unitary cells, and we identify it as the group of atoms recurrensive or even repeatedly iterated in the stereo 3 dimensions, or at the solid 3-dimensional spatial matrix, or a 3-dimensional spatial matrix to form the materials. Then we study the important, or we study the highlights, which are the HCP and the FCC and the BCC. We disambiguate and clarify most important characteristics, such as the coordination numbers and the actual amount of atoms at the cell, and the relationship between the atomic radii and the atomic or the intercellular dimensions and the atomic packing factor. We finally discussed the plans and the crystal vectors and way to read them from any cell, or the method to read them from any cell, and way to or even the way to graph them in the cell, and knowing the atomic density for the vectors and plans, then identifications of the vectors and plans groups. This is the conclusion. This is the summarization. God.